This is the second of two videos for lesson 4.3. This video focuses on factoring by grouping. So we looked at sum and difference of cubes before, and in order to factor using sum and difference of cubes, the pattern was a cubed plus or minus b cubed. So that means that you only have two terms. When you're factoring by grouping, you have to have four terms. So example 4 here gives us a polynomial with four terms. And the way you start is you break this up into two sets of parentheses. So you're grouping them into sets of two. Then you factor each set by pulling out the GCF. So the GCF of x cubed and 4x squared is x squared. So when I factor that out, I'm left with x plus 4. Now I'm going to look at the next set of terms in parentheses and factor out the GCF. I'm also going to keep this plus sign in the middle. So the GCF of 3x and 12 is 3, so I factor out a 3, and I'm left with x plus 4. Now, if factoring by grouping will work, this should be identical to this. If they aren't identical, then something went wrong. In the next step, we essentially factor out x plus 4 and see what's left. We're left with x squared plus 3, and then we have x plus 4. So essentially, we're factoring x plus 4 out. These combine into just 1, and the x squared and the 3 go into the factor at the beginning. And you can check that you factored correctly by multiplying back out. So if we were to multiply x squared times x, we'd get x cubed, etc. So the final factorization here, x squared plus 3 times x plus 4. Let's take a look at example 5. In example 5, we start the same way. We've got four terms. We group them by putting parentheses in, so they're grouped into sets of 2, and then we look for the GCF. The GCF in the first set is 4x squared, and then we're left with x minus 4. Then we've got that plus sign. In our next set of terms, the GCF is 5. When I factor out a 5, I'm left with x minus 4. Now again, these factors match, which is important. They don't match, something went wrong. So now I pull out this 4x squared and the 5 into a new factor, 4x squared plus 5, and consolidate x minus 4 into one factor. The reason this works, like if you're confused about what's going on here, imagine that you had 2x plus 2 times 4. 2 is essentially the GCF here, and if we factored out a 2, we'd have x plus 4. It's the same idea with the x minus 4. X minus 4 and x minus 4 are essentially a new GCF, and you're taking them out and putting it here and combining what's left, just like we combined the x and the 4 here. Okay, so let's delete this. All right, example 6. Put into two sets of 2. Here you want to add a plus sign and put the parentheses around negative 2x plus 3. The GCF of 6x to the 4th and 9x to the 3rd is 3x to the 3rd. We're left with 2x minus 3, close parentheses. Now remember, we put a plus sign in the middle and put the negative in with the negative 2x. So we're left with plus. Now when we look for a GCF for negative 2x plus 3, the only thing that goes into both negative 2x and 3 is 1. But then you would be left with, so let's say we factored out a 1, you'd be left with negative 2x plus 3. Then our sets of parentheses here don't match. What we have to do instead is factor out a -1 as our GCF. If we factor out a -1, so imagine you're dividing. If we factor out a -1, you're left with 2x minus 3. So we're going to erase this. Now, the sets of parentheses match. When we're combining or simplifying here, we actually don't need the plus. We can just leave it as a -1 or a -1. Okay, so now we pull together the 3x cubed minus 1 is our first factor, and 2x minus 3 is the second one. And that's the final factorization. Okay, so let's summarize the process here when you're doing factoring by grouping. You can either summarize it in your own words or use what I'm going to write down. So the first step is to separate into two sets of two terms. Right? That's the parentheses plus parentheses. Next, factor out the GCF from both sets. And then combine the GCFs into one factor. That's multiplied. I'm going to have to abbreviate here. Multiplied by the other common factor. And what I mean by the other common factor is the set of parentheses that's repeated. And that's factoring by grouping. So there are some practice problems which you can try on your own and then check your answers. I'll post the answers here shortly, or you can move on to the homework. So here are the answers and the work for 9, 10, 11, and 12. I do think practice problems 9 and 10 are really important because they are frequently missed. And the reason 9 is frequently missed is people often forget to factor out 1 as a GCF. Remember, you have to factor out something. So if there's no GCF a bit bigger than 1, you either have to factor out a 1 or a -1 depending on the problem. So here our GCFs are x squared and positive 1, giving us a first factor set of x squared plus 1, and the remainder is x plus 1. 10 is similar. 11 is standard, and 12. 12 is interesting because if this had ended up being a -4, you would have a difference of squares and you would need to factor, it again. So it would be x plus 2 times x minus 2, x minus 2. Because this is how you factor x squared minus 4. But because it's a plus, it's a sum of squares, and we know that a sum of squares can't be factored. All right, let's take a look at answers for 13 and 14 and 15 in case you want to see those as well. Okay, so here's our answer for 13, which is pretty straightforward. 14 is interesting because all of these terms are negative. So in the first step, we could actually factor out a -1, which would make this problem a lot easier. The work here is shown does not factor out a -1 right away. So you end up with this factor, -2x squared minus 3. There's a negative in both those terms, so generally we would factor that out front. So we have a negative and then 2x squared plus 3 and x plus 2. again, if you wanted to, you could have factored out a -1 in the first step and then did the rest using factoring by grouping. 15 is also interesting because if we do it the way we looked at the other problems, you end up with 2x squared plus 4 as one of your factors. But there's actually a common factor for 2x squared and 4 that we need to factor out. We can factor out a 2. So this becomes 2 times x squared plus 2 times x plus 2. You want to make sure it's fully factored. The way you can avoid having to factor this again is to, in the first step, factor out a GCF. This whole thing has one big GCF, and that's a 2. So we could have taken out a 2, and we would have had x cubed plus 2x squared plus 2x plus 4. And then we could have proceeded with factoring by grouping. So we would still have this 2 out front, but then the GCF for this would be x squared, leaving you with x plus 2. And then the GCF for the next set is 2, leaving you with x plus 2. Okay, now combine our x squared plus 2, and then your x squared plus 2, and then your remaining factor is x plus 2. So that gets us to the same end result. So again, you could factor out a GCF of 2 right away and then finish factoring by grouping. Or you could factor by grouping first and then pull out a GCF from this first factor. And that's it for factoring by grouping. So now go ahead and work on the homework.